Hello, welcome back to this lesson. We're going to continue in hypothesis testing with two variances, but now we're going to switch and talk about the left tail tests. And if it's a left tail or right tail just depends on the problem that you have. And so the problems that we've been doing up to now were all right tail because of the way the alternate hypothesis was written, and this problem is going to be left tail. So if you remember, when we talked about left tail versus right tail, it's all determined by the problem. So for instance, in the past we had sigma 1 squared and we had sigma 2 squared, right, for the alternate hypothesis. I'll put like alternate here. Now in the past, for the right tail test, it was like this. So the sign of this arrow depends upon if it's left tail or right tail test, right? But in these problems, what's going to essentially happen is the way they're going to be worded is they're going to have a left arrow there, which means they're left tail. So when you see an alternate hypothesis with a left-hand arrow where population 1 variance is less than population 2 variance, that's going to end up being a left tail test. So that's how you're going to know if you do the process in this section versus the process in the last section. The good news is, I should say, that it's really not any harder to do left tail versus right tail. But I do need to explain a couple of things. So let's go here and draw our trusty F distribution. We've been doing over and over again. I like pictures, especially in statistics, because things get confusing if you don't write a picture, draw a picture. So let's go ahead and write our F distribution like this. Not a great picture. Basically, in the past, when it was a right tail test, you were looking for an area to the right. That's what right tail meant, right? So you have F sub alpha, which was over here, giving us an area of alpha to the right. And we looked it up in the table. But since this is a left tail test, we're not going to have an area to the right. We are going to have something like this, another critical value of F, but instead of the area being to the right, the area is going to be to the left. So let me go ahead and shade this here. What do you think this area is going to actually be? Well, in the right tail test, the area to the right was alpha, our level of significance. Well, here the area to the left is going to be alpha, which is the level of significance. All right, so that's what you have to remember. Now, it's going to be the same sort of deal. You're going to have a critical region over to the left, right? And if your test statistic falls in this critical region, you're going to reject the null hypothesis. So we can go ahead and write something like that up here. In this region, you're going to reject the null hypothesis. And in this region, over here, you're going to fail to reject. All right? So far it's very similar. Before we had a shaded area to the right we called, that we said was equal to alpha, the level of significance of our problem. And if our test statistic fell into this rejection region, we rejected the null hypothesis. The only difference is because it's left tail, our level of significance is on the left-hand side of the distribution. And if our test statistic falls in here, we reject the null hypothesis. If our test statistic falls in here, we fail to reject the null hypothesis. Now, here's where things get a little bit confusing, and I'm kind of building up to it a little bit because it even confused me the first time I learned this. And I like to make things simple to understand, so I'm probably going to slow down a little bit and make sure you understand here. We called this over here F sub alpha because it was the area to the right of this value of F here. That was the area alpha here to the right of that value of F. The problem is, because alpha is the area to the left here, we can't really call it F sub alpha anymore, or we could, but it just gets confusing because this value of F does not have an area of alpha to the right. In fact, what is this area here? What is all this enormous giant area under the curve here? Right? So if this is alpha here under this curve, and the entire probability distribution, if you remember from basic statistics, always has an area of 1 under the curve, then what we're saying here is the area of this white region here is actually 1 minus alpha, because the area of the entire thing here is 1, and we already know that we wrote down that this had an area of alpha, so the area over here of all of this white space is actually 1 minus alpha. So the way you typically see it in books, not always, but typically, is you see this critical value, it's still just a critical value of F, but it's called F1 minus alpha. So if you could find a table in the back of your book or online or whatever that you could calculate 1 minus alpha, 1 minus your level of significance for your problem, that would give you the value of F with this giant area to the right of it, because all of these tables give you the area to the right, okay? Then your job would be very easy, because all you really need to do is find this value of F, and that's going to be your